All right. Professor using an open source introductory statistics book predicts that 60% of the students will purchase a hard copy, 25% will print it out, and 15 will read it online. At the end of the semester, he asked students to complete a survey where they indicate what format of the books they used. Of the 126, 71 said they bought a hard copy, 30 said they printed it out from the web, 25% said they read it online. So the professor's beliefs are going to be the expected, and then the actual student numbers are the observed. They've put that in there. So this is what we would expect. So that's why the null hypothesis goes with the professor's predictions, 60%, 25%, and 15%. This is what he believes, and he's trying to prove otherwise or test otherwise. So he's saying, this is what I think it is, and the alternative would be at least one of these probability. If one's wrong, then two are wrong. But at least one is going to be incorrect. So then we need to figure out, well, of the 126 students, how many did he expect to buy the hard copy? Well, it was 126. He expected 60% to buy the hard copy. Don't round, so this will be 75.6. He expected 25% to print it out, 31.5. And then he expected 15% to read it online, 18.9. So then it says calculate the test statistic. Well, I have to put that information into L1 and L2, so I'll go back to that, clear those out. So I have 71, 25, 15. I have, no, wait a minute. Let me check something real quick. Plus 25 plus 15. Huh? Okay, there's an issue. Oh, there's a typo here. So this is not 25. This should be 30. And 25, look at that. It says here 71 said they bought it online, so he observed 71. 30 printed it from the web, so that should be 30. And then 25 read it online. So he had the wrong numbers in the computer had the wrong numbers in the observed category. So that's going to change things. Let's see if let's just keep going with this. So I'm going to change those to the correct values. I'm going to have a lot of people get this one wrong in the practice problems because they gave you the wrong numbers. I would like to see if their answer matches up with these numbers or their answer matches up with the numbers from the actual problem. So now we'll go back to stat, and we're going to do the chi-squared goodness of fit test. Observed is L1, expected is L2. Degrees of freedom is the category is -1, so 3 minus 1 gives us 2. So we get a test statistic of 2.32. Degrees of freedom we said was 2, and the p-value is 0.313, which is going to be higher than alpha, so we failed to reject. So p is greater than or equal to alpha, so it's not this, not this. We don't accept the null. We don't reject the null. We don't have enough evidence to reject the null. And so since we can't reject the null, the data does not provide sufficient evidence to claim that the actual distribution differs from what the professor expected. So this is the correct answers. Let me just pull up theirs because these numbers don't match. They did the problem wrong. So let's see. What did they get for the first one? 2.32. Is that what we got? 2.32. 2 and 0.3. Okay, so they did it right. This is 4 decimal places, my mistake. But they set you up for failure because they used the wrong numbers in the chart. So you got to fix that and fix that.